and virtual image. And as we saw here, a plane mirror forms a virtual image. So when you're standing in front of a plane mirror, remember the image you're seeing is virtual. Now why is it virtual? Because it cannot be taken on a screen. You can't capture that image. It's behind the mirror. But a real image can be taken on a screen. And an example of a real image is when you go to watch a movie, then the image that you see or the movie that you see on the screen is a real image because it can be captured on a screen. Now one very important point is a real image is always inverted, okay? But a virtual image is always upright, or we say it is upright or erect, right? It means the same thing. So a real image is inverted, but a virtual image is always upright or erect. And now why is it called a real image? Because the light rays actually meet, okay? But can you see here that in a virtual image, the light rays did not actually meet at A dash, B dash, they were appearing to meet. We had to trace back the light rays, okay? So this is the important point, that the light rays, they appear to meet in a virtual image. So these are the important points for differences between a real and a virtual image. And the key thing to remember is real image is always inverted. So we always say real and inverted, and virtual and upright, or virtual and erect. Okay, so please remember these very important concepts when you're reading the reflection of light chapter. Excellent. So now let's talk about the ray diagram for spherical mirrors. So let's say if we have an object in front of, so this mirror that we've shown here, this is a concave mirror. Because can you see it's curved inwards, right? And this is the back of the mirror, these dashed lines. So this is the back portion here. Can you see this is the back of the mirror and this is the front. So this is a concave mirror and this is a convex mirror. And now when you place objects in front of these mirrors, and we need to place it on the left side because in front of the reflecting surface, can we see, can we predict where the image is going to be formed? So my main question is it going to be as simple as this diagram? So we did the simple diagram for a plane mirror, but what will be the ray diagram for a spherical mirror? Can we just draw the, can we just say, oh, the image height equals object height, let's put the image and then just draw the rays? Can we do that? Very good. Gautam is saying no. Ali Mullah Khan is saying no. For this ray diagram for spherical mirrors, you can't simply copy the object like we did for the plane mirror. These ones are more complicated and we need to use light ray rules. Okay, so this is an important point here, that you just can't simply draw the object. So let's talk about the concave and convex mirror diagrams and its rules. So first thing, we need to understand some important points here. So concave mirror diagram, can you see it looks like this, where it's curved inwards. So this is the reflecting surface, this smooth surface here, and this is the back of the mirror, the dashed lines. Okay, remember that. Now let's talk about the important terms here. So this center of the mirror is called the pole. Okay, this point is called the pole. And this is a spherical mirror. Now why is it a spherical mirror? Because it's part of a larger sphere or a circle, right? So can you see it's part of a larger sphere? And the center of the sphere is known as center of curvature. Okay, and where is the focus? So guys, can you tell me where is the focus of the mirror? So C is the center of curvature, P is the pole. So let me write those words here. P is the pole, C is center of curvature. And where is the focus of this mirror? Half of C. Excellent, right? So the focus lies exactly in between P and C. Okay, so this distance, let's say you've drawn it as 2 centimeters. This is also going to be 2 centimeters. So please remember that. And this line which joins the pole to the center of curvature, this is known as the principal axis. Carefully note the spelling. This is called the principal axis. So these are the important terms of a concave mirror. You have the pole, which is the center of the mirror. C, the center of curvature, is the center of the sphere that the mirror is part of. And F, the focus lies exactly between P and C. And that line joining P and C is called the principal axis. Okay, so is this point clear to you? Just be careful of the spelling of principal. It's principal, P-A-L, okay, not P-L-E. Very good. Same thing we can do for a convex mirror. So where is the pole of the mirror? It's again the center of the convex mirror. The center of curvature, can you tell me, is it going to be on the left side or the right side? Where do you think is the center of curvature of this mirror? So for the convex mirror, where is the center of curvature? On the left side of the pole or the right side? Or yeah, some people are saying behind the mirror or in front of the mirror. Very good. It's on the right side or it's behind the mirror. And it's very easy to understand why. Because when you complete this sphere or the circle, can you see? It's going to be like this. My circle is a rough one, but can you see that the center of curvature is going to be behind the convex mirror? For a concave mirror, it was in front. So be careful. And for convex mirror, it's behind because the circle completes like this. And again, the focus is going to be exactly in the center. So when you're drawing these, so this distance, right? So here, this one is going to be, let's say 2 centimeter. This is also going to be, this is also going to be 2 centimeters. So how do you draw these diagrams carefully? So basically place your compass at this point. So go and place your compass at the center of curvature and then you draw this arc and you can see the radius of the arc is going to be 2 plus 2, 4. Okay, so that's the trick of drawing either the concave mirror or the convex mirror. So again I'm repeating, place the compass at the center of curvature and draw this arc, and the radius of the arc should be 4 centimeters, 2 plus 2, and then place your focus exactly in the center. So you need to draw the ray diagrams. To draw the ray diagrams accurately, you need to draw the concave and convex mirror diagram perfectly. So make sure the focus is exactly between P and C and draw these arcs using a compass, whether you're drawing a concave or a convex mirror. These are our two curved or spherical mirror. Can you see that arc there? So this arc is what I'm talking about. You should draw with the compass and the compass point should be at C. So please remember that. Okay. Now let's go ahead and take a look at the light ray rules for a